Hi, Omar.
Hi Lee, how are you?
I'm all right, thank you. And you?
Good. Very good. Okay, so it's a 4 o'clock start. I think we should probably start now. This will be videoed, so it'll be available afterwards. So, uh, first of all, thank you all for joining us. Hope everybody is safe and healthy at the moment. My name's Omar Gina. I'm from Syrris, so part of the AGI group of companies. So it's been a very difficult time for all of us, lots of people, lots of different companies over the last few months during the COVID-19 situation. And I guess all of our working lives as we currently knew them have all been disrupted. So it is right for our business and our economy to make sure that actually we can adapt to the new changes, which I'm delighted to have Lee here. So Lee's a contract research organization based in Cambridge. And we're going to try and get an insight into what Vernalis have done to carry on being able to keep their busy laboratory running, carry on delivering projects during this time. Because of course it's even more important when you're part of the pharmaceutical sector to make sure that you can carry on delivering projects. So Lee, welcome, and thank you very much for taking your time to come and to start off, maybe Lee, if you want to just give a brief introduction to Vernalis and to the role that you have within Vernalis.
Well, thank you very much for inviting me, Omar. Delighted to be here, of course. Vernalis advances drug discovery projects in fully integrated research collaborations on targets with pharmaceutical and biotechnology companies as well as academic partners. At the same time, that's balanced with an internal portfolio of projects. In essence, our approach is a risk-shared one, and that ensures a high level of engagement from our scientists, and it's typically rewarded by their success. For technology, we integrate fragment-based approaches with a strength in structural biology and biophysics. We've got our own assay development technology, molecular modeling and medicinal chemistry expertise to enable all parts of the discovery process up to and beyond lead or candidate selection. I'm a senior team leader at Vernalis, and I've led multiple high-profile projects in collaborations.
Lee, thank you for that. Right, so take us back to March. So the UK government introduced lockdown measures. How did you, Vernalis, how did you approach your working practices?
Well, I mean, it was very important because we had critical projects underway with our partners, and we realised that momentum had to be kept going. So our first thoughts, of course, are similar to the other businesses that have been trying to operate during the lockdown and restarting, and that was how we could put in the social distancing measures. And I guess that, you know, it's perhaps for this audience easy to visualize what a chemistry lab looks like. Many chemists working in their own individual fume hoods and accessing a number of different instruments. So we had to divide up that space, basically. And, you know, our research director in collaboration with a few others were able to get into the laboratory and isolate themselves, of course, because there was nobody else in, and divide up that space into sort of three to four main areas for us in the main chemistry lab.
So thank you. So in short, of course, now we have the social distancing. So what did you physically do to your lab, and also in the instructions for your chemists?
Yeah, okay. I mean, obviously you can get some red tape out and mark out some zones for where you've got sufficient spacing. But I mean, literally in terms of like, we needed to move equipment around a little bit to be proximal to those that are working then in separated zones. And the reasons for that are we could quite easily give ourselves sort of 4-meter square boxes, if you will. There are partitions in there, and we could really work at the corners of each of the sections. So actually the social distancing is quite large, but then if you consider the next problem you have is that you will have corridors that you need to get to and from equipment. LCMS, for example, for analysis. So we had to think about how we would deal with that aspect next.
And of course, then with social distancing and fume hoods, if you have rows and banks of fume hoods, you wouldn't be able to work in fume hoods next to each other.
That's precisely it. It depends on exactly the arrangement of your laboratory, but sort of visualizing a few laboratory setups that I'm familiar with, then there's typically some areas where there are banks of fume hoods, and therefore clearly one chemist at each hood is no longer possible, and therefore you have to think of it a little bit differently. Perhaps one of a bank of 3 could be used by a synthetic chemist, perhaps, and a piece of equipment then goes in the other ones, and that's what we're having to think about enabling, in particular with the equipment moves.
And then with the reduction then of chemists being on, the conclusion of several manufacturing companies, including many of our manufacturing sites within the AGI group, has been to introduce shift work to accommodate that, while maintaining the level of output. Of course, this is slightly more difficult with chemists who have this sense of ownership of their project or the chemistry. So how did you overcome these type of...
Yeah, so there's 2 aspects to that, Omar. I think the first one was, yes, we realized that we weren't going to be at the capacity we were previously unless we did something about that, because the amount of people in the lab at any one time would have an upper limit unless we came up with some system. So what has evolved to now is effectively a shift working pattern, but we set this up early as a booking system in the calendar, and still operate that allows chemists to use the lab time for laboratory processes and still do other parts of the whole medicinal chemistry process, working from synthesis method planning. Things like that could be done from home. Plan your time in the lab, book the time and get in. So we've evolved that system now so that the shift capacity gets us up to the full working capacity, and actually gives us some room for a very tangible prospect of being able to fulfill more projects for Vernalis, and that's pretty important to our business.
Because I saw a post previously from the Timothy Knoll Group and University of Eindhoven, who also were introducing shift pattern. Is this something that laboratories are doing around the world, or is this something that you'd seen as you started implementing it?
Yeah, I mean, I follow a number of the automation guys. I think, well, because of the fantastic stuff that they do. So I follow Steve Hilton at University College London, and I also follow people like the Knoll Group and Oliver Capet. They were opening a shift pattern exactly the same week that we sent around a memo explaining to staff the full plan of how to implement the full shift pattern. So I was quite pleased that they'd come up with something very similar at the same time.
And I suppose then, coming back to the changing around how you approach projects, what were the fundamental things that you had to do to really,
yes,
I suppose it's having trust within chemists to be able to share some of their workload.
Yeah, so this is the second aspect we were touching on now, or you were touching on, Omar. It's a very important point, is that, okay, not all synthesis is linear, but a chemist likes a kind of ownership of their particular project, their particular area, or their particular compounds, even to get them to target molecules. And already in so one chemist might be making them that then gets used by numerous chemists to get to multiple target compounds. This is not unusual. And also within the project teams themselves, there's the integration of extra automation. So for example, myself and work in flow chemistry, we've been trying to augment projects by perhaps providing them with where flow can make an impact within the projects, and that was already underway. So, for example, we prepared an intermediate that's synthetically challenging, and that enabled the project team to get a number of targets out with that motif that was then installed by another chemist. So the chemist has less ownership of a molecule itself. It's more of a team effort to get to the end target. And that is a difficult concept for chemists to then change their working ideology towards that end, yes.
Absolutely. That would have been a big challenge for me when I was in the lab, I could imagine.
Yeah, exactly. Hands off my stuff.
Yeah, exactly. Or the contrary, please just complete all my stuff and I'll head off and have a coffee.
That's right.
So I guess now you've kind of talked about the human element and you've approached that subject, the shift work, the lab facilities, how you've changed around to introduce all the social distancing measures, and also about all your collaborative work together in projects. I guess automation and chemistry, now it's time to get on and do some chemistry. So automation was a key here. So do you want to explain and expand a little bit on the automation that you have and you work towards?
Yeah, so we'd set ourselves a significant challenge in automation already to impact one of our projects, one of our highest priority projects within the company. And the synthetic challenge was almost conquered really by the time, in terms of developing it as a flow route, by the time that the government lockdown was in force. A lot of the development work is done in a collaboration with myself and Daniel Maddox at Vernalis. And it's fair to say that the most experienced flow chemist we have is Daniel Maddox, and to 80% through getting that method developed and running. Unfortunately, Daniel was having to isolate, so there was no chance of me being able to have him in a shift for at least the next 14 days. So there became this tantalizing prospect of being able to push it forward by automation, but then it was trying to enable it to do that. And that was really what got us excited about, could we actually do this? And we made a key step in really making sure that our flow system could be accessed by a remote desktop protocol, as we would similarly from the office, but the difference is that Daniel was at home. And we got quite excited about that prospect and then planned the synthetic, the campaign. We planned it out in the lab book completely. So I only had to go in for a few hours actually with a set of instructions. I became the gopher, and then Daniel did the chemistry. So literally I went in and loaded him up with enough reagents to run, and Daniel ran the system from home.
And did you need to do anything specifically to get that all working remotely from home?
We had a couple of issues with some comms systems, which were kind of a bit local really, to our particular setup at Vernalis. And it did take us a little while to get over the frustration of that. I mean, in the end, it was a sort of an electric interference on one of the comms cables. The Asia is a system, it defaults to safety. So if it loses any comms with any part, the whole system shuts down. So you can imagine that's not particularly useful if you're at home.
Yes, but better than any catastrophic event, I suppose.
Exactly. I mean, it is an instrument that needs every component to be running. And as I say, that particular feature was local to us, and therefore it causes a little bit of frustration trying to work it out. And really, in the week before the government lockdown, we were trying every different combination of comms cables and managed to actually fix that. And that was the excitement, that we could watch the Asia in a test run, watch it just stable actually, and operate it. And we could do that over a 48-hour period. So then it's about, well, let's get it doing some chemistry. Then it's doing chemistry for us while we're out of the lab.
And you mentioned about watching. So one of the things I know you've implemented is a series of webcams on all the key areas. I don't know, maybe do you want to share your screen and show
Yeah,
us what you can currently do?
let's try that if we can. I'll try and share my screen with everybody. I can show anybody who's unfamiliar with an Asia system a picture of the Asia system. Okay, so hopefully, Omar, you should be able to see a picture of the Asia system.
We can, I recognize it.
Please give me the thumbs up.
Yeah.
Okay,
absolutely.
so I mean, in a similar way to the nomenclature of Lee Cronin and his computing, this is in separate sections. So yellow is a pump, the green is the reagent injector module. So this does all of the hard work of loading these loops ready for injection into the system. And then in red boxes are two reactor modules. One of them is a tube heater. The second module is a column heater. And on the far right, you have a Gilson fraction collector with the back pressure regulator installed on top. So that gives you the view of what you're actually seeing. What you're actually seeing now on the next view, Omar, I hope you're seeing a row of reagents.
Yep.
Are you, Omar?
Yes, yep. Yes.
Okay. So here's a row of reagents, and you can see that the reagent injector module is taking an aliquot from one of the reagent bottles there, ready for the reaction. In this particular case, this is an acetylene in solution. If I go to the next, I can show you another view of it. So this is the other channel that we're operating here. Hopefully you can see another row of reagents.
Yes.
These are a bit darker in color because these are the aryl mixed with several other catalytic components. So we have an aryl and an acetylene. So the reaction that we're performing here remote is a Sonogashira. For those of you familiar with that. We've also got a view of the pumps and also our solvent reservoir. So this is how much juice you've got in the tank, how much carrier solution you've got. And these are all the checks that you would like to make if you were doing any reaction. Asia system gives you a rundown of all of the modules in a run log. So you can see exactly what operation it's doing now, what operation it's going to do next. And you will also see any fault that occurs. And it can be quite frustrating if we're in any automated run. You may have been doing chemistry where you set it running overnight and you don't really know till the next morning whether you've got success or not. And this is the same thing. But with the cameras, you can actually see that your pumps are operating okay and everything's running expected, typically as you would in a lab setting off an automated run at the beginning.
It actually just mimics exactly what you do in a lab with regards to my solvents, my inputs, my outputs, and my pumping.
Yeah.
So, yeah.
Yeah, it's as close to as being there. Yeah. The other thing that you can monitor is the fraction collector. So you're seeing a view over the fraction collector here. So you can see the arm is in position collecting a particular fraction. And this was how we were able to test the system over remote desktoping. Able to practice moving about the arms and see how that worked for us, if we went for a run for real.
And you mentioned remote desktop, and so this is all just standard remote desktop through to a PC that's running the control software.
That's right, in the same way that we remote desktop to use our ELNs and any other system. Included in here, I've got one of the steps, which is obviously the evaporation step. So I'm showing here an after step where we would typically think about the synthesis and then evaporation and purification processes. So one of those is evaporation, a number of fractions. So this is a Biotage V10, and you can hopefully see all of the vials there ready to receive products that would be either directly from the Asia itself or from a workup post the reaction from the Asia. And they would be then vac down into vials ready for the next batch reaction, in fact, where we're sewing in our flow step with batch reactions subsequent. Okay?
You mentioned there's kind of a couple of questions from this then.
Yep.
Obviously, the synthesis is one part, so now you're showing also the evaporation. What about other workup and purification? Have you got all those automated as well?
So yeah, so there's a number of steps that have been either automated or they've been equipment for parallel chemistry for some time. So what we've done is gather those bits of equipment for this particular case to push forward from this diversity step through a number of parallel steps. The Biotage V10 is one more modern piece of equipment, but we've also gone back to look at reconfiguring the Waters mass-directed LCMS system. And we've written, Steve Ruffley has written a 9 protocol that allows us to output a CSV file that can be uploaded directly to that machine. And with a couple of adjustments, that machine's operating quite well on a test run for us. So we tried to line up all the parts of the process that mean we can follow up from the synthetic step with the flow chemistry.
Okay, and then I guess when you mentioned this goes on to a batch step, I mean, flow chemistry and batch, it complements batch chemistry very well. How has been the impact? Like, how has the impact of flow chemistry been? Have you seen an uptake of more of your chemists moving over to flow?
Yeah, I think it's a different challenge that flow chemistry has in a medicinal chemistry setting.
Lee, I'll just interrupt you a second. Possibly you just stop sharing your screen.
I think if you were to look at impact, okay, are you a bit slow? We can try and speed things up a little bit, yeah?
No, the audio was a bit slow on that. So if you want to just repeat the answer to that question we didn't get.
Yeah, sorry about that. This is something I have to bear in mind. There's a lot of traffic on this, and obviously we're trying to share as well. Yes, flow chemistry has made big impact in the process chemistry world. I think that's known if you're in that arena. It seems a separate arena as the medicinal chemistry. And in order to make impact into medicinal chemistry, a continuous process has to have diversity as well. So how can you have a continuous process with diversity? But one of the ways that you can do that is focus on perhaps a bottleneck step, a rate limiting step, and where particularly the aspects of flow chemistry could help that particular step. So it may be a mass transfer or heat transfer. It may be a critical control aspect. So I'm thinking back to where I first got started with flow chemistry really properly. And that was when, after the 2018 publication in Nature Protocols by Jesus Alcazar, where he was doing on-demand organo-zinc reagents, okay? And we were having to, we had a project where we were needing to form we were needed to do a Negishi coupling. So there was some chemists who had the skill to enable the zincate formation, and they'd repeat it again on a scale. And this was a problem. And at the same time, Alcazar published on-demand organo-zinc. So I was fascinated by this paper. The SI is incredible because it even tells you where to grease the joints. So the detail in that paper was incredible, and I was able to repeat that and generate, as Jesus suggested, on-demand organo-zinc reagents. So that made a big impact to that project, that step was conquered, and now we don't return, we now do Negishi steps in flow.
Okay. Brilliant. Yeah, no, I'm aware of the Negishi work from Jesus Alcazar. It's fantastic. I'm also, you mentioned before about some other automation people. So Lee Cronin's automation, I think he is the Zoominars that are currently ongoing. That
like this one.
Very interesting. So where do you go next? So you now have the lab up functional. I do know you're someone that likes your toys and keeps progressing things. So where do you take the chemistry from here?
Yeah, you know me well, and if anybody out there is interested in Lee Cronin, then please look him up. He should be easy to locate, and he's done some fantastic Zoominars on his chemification, chemify.com. So if you look at him, look up Lee Cronin, then you'll see that Lee Cronin has a very big ambition to basically automate the process from even machine reading lab protocols to directly into automated synthesis. We're just taking smaller bite-sized pieces and trying to, as I say, focus on those key steps where we can automate those, use the advantages of flow chemistry to progress them forward. Where we see it now is that we have made big impact with the automated system. It's very busy and it has a number of internal customers now, and we're being asked, can we impact a number of projects? So what I see the future going forward is that we would probably generate a way of having a method development set up. So we could work on a flow system that we could develop the method, get that robust while we've actually got a machine that's already, you know, busy with automation of something like the Sonogashira that we currently are doing at the moment, like the Negishi couplings that we've already embarked on.
Okay, wonderful. So I suppose the question then for management or for the business impact is how has your business been impacted? Are you still as busy as ever? Are you still delivering those projects? Have you able to hit all the projects over the course of the last few months?
Yeah, no, I think the endeavour of the research director, I know, and he, obviously as his team, we've helped him as much as possible. He has delivered on that. I think Vernalis, more than that, the business is going very well at the moment. So we are aware that we have the necessity to run at this speed and more, and we think we have enabled that with our approach to the current situation. The current situation looks set to last for some time. So we think a survival of the fittest here is to adapt very, very quickly. And we think we've been, you know, quite ahead of the curve there. And I think now you can see that we have delivered on the projects we have now, and we have capacity to increase.
Okay. I like that, survival of the fittest. And probably finally, because we're coming up to our 30 minutes, so there'll be a number of people that will see this recording or will be on the line that are in a position where their lab has been closed. So any kind of lab managers, what advice would you give them to be able to get their labs up and running?
Yeah, that's a great question, because I guess, and there are a number of labs out there that are either initiating the process or they are looking whether to start up again. I think we had to get going very, very quickly. So we had to sort this out and evolve it a little bit while we were going. So if you've got the time now and you're out, I would recommend, you know, have your meetings like this and strategically plan it. The strategic planning should go into that much extra detail, not just division of the laboratory space, but exactly how you want to progress your projects in that type of environment. Think very much about the corridors and spaces, you know, so that, you know, you're not creating traffic through zones. All of that's really important. And then you've got to work with your teams very closely. So to use as many of these tools as possible, get everybody working together as a project team. And if chemistry can pick up the bits of the project that need progressing forward and the highest priority, then individuals can make impact that way as well.
Wonderful.
So that's what I would recommend. I would recommend looking at all of those aspects. And it's not just a case of zoning up the lab. and maybe automating all of it. It's about looking strategically at what you need to do to enable you to function in this environment and for potentially a protracted period.
Great. Well, Lee, that brings us up to the end of the session. Now, I was going to open this up to some questions.
Okay.
And to do this via the chat, but I know that we've had to disable the chat function. So I'll just cut to Michael, if you're there.
Yeah, I've just made you the host, Omar.
Okay.
And I'll just allow people to send you a message only.
Okay, so if anybody has any questions, please, if you were to just go to the chat function and send it to me, so Omar Gina as the host. I probably have one here just as we're waiting for any questions. We've just got enough time for a couple of questions, but one will be, you've now streamlined many different things. Has that increased? Has it introduced any new bottlenecks in your processes that you're needing to overcome?
I think we'll probably want to look at more of the stages of the synthesis and where the convergent synthesis comes in next. I think it would be nice to pick up parts of the synthetic process where we can enable sufficient of the intermediates so that the target molecules can be made faster. So that's where we'd want to look at next. I mean, we create somewhat our own bottlenecks further down with the batch chemistry and workups, etc., but they're not insurmountable because the library sizes are not large. They're quite targeted. And you know, the scale that we're working on is sufficient in each one to get through a number of steps. So I think where we could make impact next, I think, would be to look at whether we can facilitate generation of key intermediates that then progress everything further forward across the project team. I think that's somewhere where our management are looking to see if we can make impact there. That makes a great deal of sense in that as well going forward, because it may be another stage of the synthesis that you've converted over to a continuous process, which ultimately successfully could lead on to, you know, something that could be piloted in a continuous process sense in a development phase.
Well, Lee, I think we're kind of out of time there. We've come just over half an hour, so I think we'll call it a day there. I would like, first of all, to apologise to everybody for being Zoom bombed, as I believe it's called. So for any bad language or anything else you've seen or heard, I apologise for that. We have had some technical glitches earlier on today, and we weren't really quite ready for that extra music and different other things that came through. So apologies for that.
There is one question.
So is there?
Another question from Kevin. What about this is a question for Lee. Yes. What about automated flow electrochemistry?
Well, that's a very good question, because there is the potential to do automated flow electrochemistry. And in fact, there are good publications from Kevin Lamb and others on exactly that. So Steve Hilton and Kevin Lamb worked in collaboration. They have a piece of kit that they've bolted onto one of the ICA Electrosyn. I know that other flow chemistry vendors also supply equipment that does that, but Syrris also have a module that you can perform electrochemistry in called the Flux module. And that's something that we've looked into as well. There's some great publications in electrochemistry, including from Kevin Lamb, and I've repeated some of his work. And there's the potential, of course, like the Knoll group, to investigate whether you could have sort of home-built reactors. But you know, it depends. The academic groups have a bit more blue sky than industrialists, and we need to get on and get things done. So typically we might look for a kit that's been designed. So as I say, there are commercially available flow chemistry kits for doing electrochemistry. And these guys at Syrris, they actually sell a unit called the Flux that can do exactly that. Have you got anything to add to that, Omar?
No, I think
on electrochemistry.
I think you covered. I think we're seeing a large increase in both electrochemistry and photochemistry, especially at all the conferences around. So it's like what anything with flow chemistry was many years ago. Electrochem, flow, and photochem are really coming in. Some great publications, great talks, and I think it's only a matter of time that really just comes into the everyday toolkit of a chemist.
Yeah, I mean, so yeah, exactly. I mean, if Kevin had have asked about photochemistry, then we've already done quite a bit of photochemistry on the Asia module. And we've also repeated the follow-on paper, 2019 paper by Jesus Alcazar, which is a photo-enhanced Negishi coupling. And I think, well, it's fair to say that there we've shown there is a proportion to the amount of irradiation that you can expose that reaction to. So we've shown a proportionality there. So Jesus was very nervous about that paper, and he got some criticism because of it being photo enhanced. But there is a clear correlation between the amount of light and the amount of coupling, the amount of conversion. So again, it's a great publication by Alcazar. Please look that up.
Great. Thanks, Lee. Michael, is there anything else, or should we?
No.
Cool. Okay, so thank you for all of those of you who have attended today, and a very big thank you to Lee for taking his time. Apologies for the little glitches. We were going to cut to a remote desktop into the lab, but we also knew that the general bandwidth on the Wi-Fi was causing the vocals the voice to drop out. So actually we couldn't do that in the end. So, you know, it's like what we're all used to now is all these little glitches. I've had my little daughter crying in the background and everything else. So, but I think it's, as we've seen today in Vernalis, we overcome them and we still deliver our project. So well done to you and the team at Vernalis. And thank you all for attending.
Thank you, Omar.